Okay, here the question. This question is very important question and obviously conceptual. Question is how many grams of ice at minus 14 degrees centigrade are needed to cool 200 gram of water from this to this. Take specific heat of ice as this and latent heat. See what is happening. Let us suppose some m gram of ice I am taking. Okay, some m gram of ice I am taking, and we are putting those cube blocks or those ice blocks inside 200 gram of water. Okay, so basically this 200 gram of water was having initial temperature this much, 15 degrees centigrade, and temperature changes from this to this, so there is no phase change or state change of water initial, right? Initially 200 gram water was there or at 25 degrees centigrade, and at 10 degrees centigrade obviously the water will be water. Now in case of ice, what is happening? In case of ice, since you are putting ice blocks or ice cubes, what was its temperature initially? Minus 14 degrees centigrade, and what is happening? It is also becoming 10 degrees centigrade. Na? So ice of 10 degrees centigrade is not possible. So obviously ice is melting. That means state change is coming. Okay, at first from minus degree centigrade ice, its temperature will rise. Okay, up to how much? Up to 0 degree centigrade of ice. Then a state change will take place here of 0 degree centigrade, and it will become water. Then after becoming water, its temperature will rise to 10 degree centigrade. So this is the whole process. Okay, this is the whole process for ice. This is the whole process for ice. Now concept is clear, and this is ice is taking heat, ice is gaining, so here heat gain is taking place. So let me clarify the thing once more. Fact is that for water, what is happening? For water, what is happening? Its temperature simply rises from 10 degree falls from 25 degree centigrade to 10 degree centigrade. So heat lost for water, right? Heat lost, how much? Delta Q is equals to only temperature change, no state change. So m of water, s of water, and delta theta, that the change in temperature. So what is its value? M water was 200 gram into S water. All the units are in a CGS system, so no problem. S water in CGS system is how much? Specific heat is 1 calorie. Okay, so 1 calorie per gram per degree centigrade. So 1 into delta theta is how much? From 25 to 10 it is going, so actually we need change. Okay, so it will be 15, so 3000 calorie. This much of heat is lost by the water, and heat will be gained by the ice. So for ice, what will happen? For ice, heat gain. And what are the processes? Let me write down the process. Like minus 14 degree centigrade, it was ice of mass. How much? We are taking m gram of mass, so m gram. Okay, and its temperature at first will rise to 0 degree centigrade, and it will be in ice form till now. And then state changes from 0 degree centigrade to 0 degree centigrade, and it will become ice to water, and then its temperature will rise to 10 degree centigrade. Okay, and obviously it will be water. So water to water, no state change. So where state change takes place, their formula of delta Q is what? That is m into L. Here it is fusion process, so LF, LF. And for this case, delta Q is equals to how much? That is mass into specific heat of ice into simply change in temperature, delta theta. Here also, because change in temperature is taking place, so m into S water into delta theta. Now put all the values and sum, add all these terms, because these are the total heat gain. Okay, so what it will be? M we can take common. S ice is 0.5 into delta theta, means from 14 to 0. Always take positive sign. No need to take, means we need only difference. We need only difference. So difference from 14 to 0 is 14, plus latent heat of fusion is 80 calorie per gram, plus mass is already common, water of water is 1 into delta theta, from 0 to 10 it is going, so 10. What we are getting? So m into 7 plus 80 plus 10, so 97 m we are getting. So this value, this much calorie will be equals to this much calorie. Now what is the answer? How much amount of mass will be required? How much amount of ice will be required? In gram unit obviously we'll get, right? Calorie, whatever we will get in gram unit. So m is equals to, 1 second, m equals to 3000 divided by 97, because heat gain is equals to heat lost, right? So the answer will be nearly about 100 or something above 100. No, not 100, 300, above 300 gram, obviously in gram unit it will be. So just calculate this term, not 300, sorry, 330 something, 30, 31, 32 something will get answer, because 97 is close to, means 100. Okay, you can just calculate it and you will get the answer in gram unit. So this kind of questions are very important for exam purpose. Okay, because these are one of the easiest questions from this chapter, from thermal properties of matter. I hope you have no doubt. If you have any doubt, you can comment in the comment section. Okay, thank you.